Okay, so I'm going to go over 8 of the 23 problems that were assigned for homework tonight. Again, the 2 pages that were assigned for homework were page 26 and 27 of the handout. And that was the back. It was called Skills Practice and Practice at the top from 8-4 from my old geometry textbook. So now, this is all about trig. On the first problem, they give you a triangle over here off to the side, and they give you the lengths, and they ask you to find the sine, cosine, and tangent of both r and s. So if we're using this triangle, first thing, I'm going to go ahead and write out SOHCAHTOA so that I remember what everything is. So SOHCAHTOA, which is sine equals opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, tangent is equal to opposite over adjacent. Now, the triangle that they have here, well, each one of these problems uses it, but they give you different numbers. So I'm going to redraw it real fast and plug in the values that we need for this current situation. So we have R, S, and T. Now they said that little r, which was over here, is 16. S, which is across from S, is 30. And T, which is across from T, is 34. And again, they told us that this is a right triangle. So we can use our trig ratios to set up a ratio for each of these pieces. So first, listing out sine, cosine, and tangent. So we have of r, I'm going to do all of r first, because once we do one of the angles, we can actually get away with not having to look at the triangle for the other angle, since the complements are related to each other. So sine of r, cosine of r, tangent of r. So sine of r, sine is opposite over hypotenuse, so here's r. So based on r, 16 is the one that's across from r. This would be the opposite. So we have 16 over the hypotenuse of 34. That could be reduced. 16 and 34, let's see. I think the smallest you can reduce that to is 8 over 17. So then we have cosine of r. So again, cosine adjacent over hypotenuse. So 30 over 34. Again, we could reduce those both by half, so that'd be 15 over 17. And tangent of r, opposite over adjacent. So 16 over 30. And again, we can go down to 15. Oh, sorry, I just reduced the wrong one there. 8 over 15. And those would be our values for r. A little bit there. So now that we have those, we can go and do the other side of this, which would be S. Because now that we know these, we don't really have to do the work for the second half. I don't even have to look at the diagram. So I have sine of S, cosine of S, and tangent of S. Again, the sine of one angle is equal to the cosine of this complement. So again, these angles have to be complements. They would add up to 90. Any two acute angles in the same triangle add up to 90. So cosine of S has to be equal to, sine of S has to be equal to cosine of R. Cosine of S has to be equal to sine of R. So I already know this one is going to be 15 over 17. And this one's going to be 8 over 17. The tangent of S is going to be the reciprocal of this one, so 15 over 8. Now, if you wanted to go back and refer to S to check these, here's S up here. The opposite is 30 this time. So it would have been 30 over 34, which reduces to 15 over 17. Cosine, adjacent over hypotenuse, 16 over 34, which reduces to 8 over 17. And then opposite over adjacent, 30 over 16, which reduces to 15 over 8. All right, going on to number 3 down here. This one's just basically plugging into your calculator. So it just wanted you to find the decimal around to the nearest hundredth. Now, depending on your calculator, it might give it to you as a decimal, it might give it to you as a fraction. So if I'm using this calculator, we're going to have sine of 30. Again, have to make sure it's in degree mode before I start anything. Gives it to me as 1/2, or if I change it, 0.5. So let's wind it as a decimal. So we have 0.5. And it said to the nearest hundredth if necessary. We don't have to round this, it's just 0.5. If I did it in the other calculator, this one, oops, I typed in 30, and then after typing in 30, then you hit sine, and you get, again, 0.5. And you could also do it on a cell phone if you turn it sideways, but you should get 0.5 no matter what. For the next set, I'm actually going to do 2 problems here. I want to do number 11 first, and then I'm going to do number 10 at the very end of this video, so I'll come back to that one. So on number 11, now we're actually solving for a triangle. So we have 3 parts. Again, in order to use these ratios to solve, you need 3 parts. One of them is what you're trying to solve for. You have to base everything off of the angle you're solving for. So again, we're going to use either sine, cosine, or tangent. So let me write it out again. SOHCAHTOA. SOHCAHTOA. So we have the 15-degree angle. The one that's given across from it would be called our opposite. The one over here is across from the right angle, so that's our hypotenuse. So if we have opposite and hypotenuse, again, it has to be one of these 3. The only one that uses opposite and hypotenuse is sine. So sine is the one that we're going to use. This is adjacent hypotenuse. I don't have adjacent. This is opposite and adjacent. Again, don't have adjacent. This is the only one possible to use. So now I set up an equation. So sine of the angle measure is equal to opposite over hypotenuse. So x over 12. So now we have to solve. Now it's algebra. So we're using algebra to solve this. If you want to plug that into the calculator and get a decimal first, you could. I like to not round into the very end. So I like plugging it all into the calculator at the very end. It doesn't matter what type of calculator you have, as long as you understand how to plug it in at the end, that's fine. So we multiply 12 to the other side, cancels off. So now I know that 12 times sine of 15 degrees equals x. On this calculator, it's very simple. Now, you gotta remember, come say at the end of the year, you'll have a calculator like this type of calculator on the computer, whereas you have this type of calculator as a handheld. So I would be comfortable with using both types and know how they work. So we have 12 times sine of 15. I typed the whole thing in. If you want to close the parentheses, you can. Don't have to. That gives me some crazy answer. Again, this calculator is simplifying radicals. I don't want that answer. I hit the double arrow key and it changes it for me to decimal. And it told me round if necessary to the nearest hundredth, which is 2 decimal places, so that'd be 3.11. So I have 3.10582 blah 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 equals x. I'm rounding it off to 3.11. Again, that's my answer. Now, on number 12, this one is not looking for you to solve for a side, it's looking for you to solve for an angle. Again, it's still the same type of start. You have to determine which one of the ratios can we use. So, this is the angle that we're solving. We still have 3 parts. And then on this one, again, we have our opposite. We have our hypotenuse. So again, this one is also sine. Now, setup is pretty much the same as the last problem was. Although I don't know my angle measure. So when I write this out, I have sine of x degrees equals opposite 6 over hypotenuse 18. Now, if you want to reduce this side, you can. Again, you don't have to. I could plug it in just like this. Or, if you want to change it to a decimal, well, 6 over 18, that's 1/3, or as a decimal, that's 0.3 repeating. Now, if I was to plug that into this calculator, well, my next step here, I need x by itself. I gotta get rid of sine. I'm doing the inverse. Anytime you solve for an angle, that's where you do the inverse function. So inverse sine of 0.3. Or again, you could also type it as 1/3. In this calculator, I'm comfortable with doing either. I could either do inverse sine, so second sine, and then type in 0.3 like that. Again, it gives me a rough answer. But if I do that compared to the 1/3 is a little more accurate. 1 divided by 3, and I can do it like that as 1 divided by 3. Again, notice, very similar. I'm only rounding off to the hundredths place, so up to the hundredths place, either answer gives me a good answer. However, let's say I had done just 0.3. Would I still get a good answer? Now that's completely different. So you need to make sure you use at least, I'd say 3 to 4 decimals until the very end of a problem using sine, cosine, and tangent, because you may have to round at the end, but if you rounded this compared to rounding that, two completely different answers. So make sure you include enough decimals until you get to the end. We don't want to have too much rounding error. So the correct answer here was, again, this one. Let me re-enter it. There it is, 19.47. All right, so now on to the other page. I'm going to do a couple problems from there. Again, this is very similar to the first problem, except now we have a radical. So you may have to simplify a radical, or you may have to rationalize a denominator. So again, you just got to plug them in and see what happens. So let's plug it into each of these parts. I'm just going to go ahead and label the figure this time. 12. M is 12. And this is 24. Hey, you know what I also notice here? These values are the values of a 30, 60, 90 triangle. Notice, we've got the short leg, times 2 is the hypotenuse, times radical 3 is the long leg. If, say, you wanted to just do the sine, cosine, and tangent of 30 degrees and 60 degrees, I already gave you those in the notes. You get the same answer, all right? Or if you recognize that, we could actually just say, instead of saying sine of L, sine of 30, plug it into the calculator, see what it gives us. Because it says you could write as a fraction and as a decimal to the nearest hundredth. So on here, if you wrote it as a decimal, that's fine. If you wrote it as a fraction, that's fine. Both answers were acceptable. Now, some of these I would probably not as decimals, but it's up to you. Whichever one you want to do, that's fine. Let me make sure I posted the right thing. I just realized I may have posted something wrong on Edsby for you guys. Yep, I posted the wrong thing. Alright, I posted the wrong set of answer keys. I'll correct that when I'm done with the video. Okay, so on here we have L12. We have them all labeled. Okay, sine of L, cosine of L, tangent of L, sine of M, cosine of M, tangent of M. Sine, opposite over hypotenuse. So we're going from L, opposite is 12, hypotenuse is 24. That reduces to 1/2 or 0.5. Cosine of L, adjacent over hypotenuse. So 12 radical 3 over 24. This reduces both those by 12, so this would just be 1/3 over 2. Tangent of L, opposite over adjacent. 12 over 12 radical 3. Well, the 12's reduce, so this is just 1 over radical 3. You'd have to rationalize, multiply both bottom and top by radical 3, so you'd get square root of 3 over 3. And that'll be our final answer. And you'll notice if you look at our notes from the other day, all those answers are there because L is in the place of the 30-degree angle. So if I look at all my values for the 30, look, we got 0.5, we got 1/2, we got radical 3 over 2, radical 3 over 2. This one, oops, I didn't show the simplified version there. There it is, radical 3 over 3. So again, you could use those. Again, all these are going to match up with these. So we have the first one. The first one's going to be the same as this, so square root of 3 over 2. And the sine of this one's equal to cosine of that one. Cosine here is equal to sine of that one, so 0.5. And then this one, oh, it's a reciprocal. So go back to before we had rationalized it. It was just 1 over radical 3, so radical 3 over 1, or just square root of 3. And that's our answers. All right, on number 4, we have a triangle, and we're solving for the side. Now, we're using this angle. This part would be the adjacent leg. This would be the hypotenuse. So if we talk about SOHCAHTOA again, SOHCAHTOA, we have adjacent and hypotenuse. That's in cosine. So cosine of 29 degrees is equal to adjacent x over the hypotenuse of 29. Now, multiply this 29 over to the other side, so times 29 times 29, and plug it on in. Now, I used the blue calculator last time. I'm going to use this calculator this time. Because again, you can plug that whole thing in from this point. So this is what we're multiplying out. And we have to do the cosine part first. So 29 cosine. And again, if you want to write that out as a number first, you can. And then that times the 29 that's over here, so times 29 equals 25.36. Right, so again, we had x equals 25.36. That's our final answer. Now, number 6. This time, we're looking for an angle measure. It says find B. Here's B. The two parts we have. This is across from it, so that's the opposite. And 8 is next to it, so that's the adjacent. So opposite and adjacent. Which one is that? Well, again, if you need to, write out SOHCAHTOA. Opposite and adjacent, the only one that has that is tangent. So tangent of the angle measure, which we don't know, so we're just calling it B, is equal to opposite, 14, over adjacent, 8. Again, if you want to, you could go ahead and divide that. So I'm going to use this calculator this time. So 14 divided by 8. If you want to change it to a decimal first, you can. So that's 1.75. The tangent of B equals 1.75. You gotta get rid of the tangent part, so that's where you do the inverse tangent. So B equals the inverse tangent of 1.75. So we have that on the calculator. Second tangent, 60.255, which that would make it round up, so 60.26. 60.26. And again, that's in degrees. And that's it. Now, I did say I was going to do one other problem, and the reason why, if you go back to number 10 on the first half, there's one extra step involved here. And it's because of what values are given to you to use in your fraction. So, let's take a look at this problem. We have this angle. We have, based on that angle, we got the opposite, and we have the hypotenuse. So this, again, will also be sine. Now, I'm going to show my work over here, just so I have some room. So sine of my angle, which is 63, equals opposite, 12, over hypotenuse, which is x. The x is in the denominator. First, we got to get the x out of the denominator by multiplying it to the other side. So multiply x to both sides. But we're not done, because now we have x equals sine of 63 equals 12. x in by itself. Again, this is all algebra now. We got to get this over to the other side. So divide off sine of 63. And you get your answer, which you can plug that into the calculator to get your answer. Again, doesn't matter which version. If I do this one, I'll show it on both calculators this time. 12 divided by sine of 63, 13.467, which will round that up for 13.47. If I had done it on the other calculator, again, I can type the whole thing in. You just got to be careful with how you type it. 12 divided by 63 sine equals. Again, I type the whole thing in. You just have to know how to type it in. So again, if I'm doing it in this calculator, I type the 12 first, divided by, again, in order to do the sine 63, I have to type 63 next. I hit sine. That's not my answer. That's what this denominator currently is. I have to hit equals before it actually does the division part of that operation, which again gives me this. So those are those problems. I'll repost the correct answers on Edsby since I posted the wrong ones. Sorry about that. Again, hopefully I can answer more questions tomorrow, and we'll be doing this all day tomorrow.